This is Max Headroom, and what you're about to witness is one of the most sinister-sounding intros to a trailer to one of the greatest epics ever produced in the history of television. And there's more, because you are going to see it as well.
Yes, it.
Yes, it. Yes, namely...
Geometry. Yes, you heard it right. Geometry. I'm your virtual learning assistant.
I will survive. Oh, as long as I know how to.
Sorry. Where were we? Right. Lesson number 9 and 10 today. Go do these lessons, but I just want to remind you guys, when I post these videos, I also post, okay, what are you doing? All right, stop it. Okay, all right. I also want to remind you guys that I post the blank notes. So if you have a printer available, go ahead and print off a copy of these, and you can follow along. And when I come to a problem, you can pause the video, see if you know what you're doing, then watch how I do it, or let me do it first, then pause and see if you can do it after I've done it, whichever way you want to do it. But use these notes to help you. Don't just watch and then try to do the practice problems and not sure if you did it right or not. All right, so something to work on there. So let's get started. Move me out of the way a little bit. All right, so we are on equations of lines today. So let's first refresh ourselves remembering slope. Let's remember that. Okay. All right, the slope of the line in the image is 8 over 15. Explain how you know this is true. Remember, this is linear. This goes back a ways. You learn in linear 7th and 8th grade. 8 over 15, that's rise over run, right? Rise over run, which means it would be a rise of 8 and a run of 15. So this is at -6. If we rose -6, it would raise it up to 2, right? See, that is going up from 8. So from -6 up 8, 1, 2, 3, 4, 5, 6, 7, 8. That's the rise, 8. Run of 15, it's a -10 is the x coordinate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Puts us at 5. So that would be the rise over run. Little refresher there. We can get it by subtracting those. If we didn't have it on the graph to be able to count it, we know we end up at 2. We started at -6. So remember, it's the difference in the y's over the difference in the x's. What's the difference in the y's? So the x's is 5 minus -10. So 2 minus a -6 would be 2 plus 6, so that would be 8. 5 minus -10 is the same as 5 plus 10, 15. So we can get it just algebraically with the points if we don't have the graph to be able to count how much it goes. So either way we're subtracting the difference in the y's and putting it on top, subtracting the difference in the x's, putting it on bottom. Difference of the y's of the x's. So a little refresher there for our start today, because we are going to be working on building an equation for a line just a little differently here. So let's look. The image shows a line. Yes, we see a line. And there's 2 points on the line for us. There's a point here at 1, 3, and then this XY point is just kind of out in space. It's not on a actual coordinate point that we can easily discern. So write an equation that says the slope between the points 1, 3, and XY is 2. Okay, what do you think on that? So if we're wanting to determine the slope, remember, so it's the differences in the y's on top of the differences in the x, and it should equal 2 in this case, because that's what the slope equals. So the y, we know this y is y, so y minus, and it started at 3. So that's how much the y has changed. It went from 3 all the way up to y, however far that is. And the x's, it ended up at x, and it started at 1. So y minus 3 divided by x minus 1 should be a slope of 2. Now we can look at the line and tell that it has a slope of 2 because it goes up 2 and over 1 to this next point. We have a point down here. It went up 2 and over 1. So we can see it is a slope of 2. It's just our xy is not on one of those points that we like to use so much in determining that. But it should also be a slope of 2 from there to there because it's on the line. So it would always have to be the same slope anywhere on that line. So let's look at this equation here. Let me highlight that. Y minus 3 equals 2 times x minus 1. How does that relate to what we wrote? Let's take the graph off the screen here and just look at the equation. So this equation with what's highlighted. Well, this is just the same equation rearranged, right? Same rearranged. How was it rearranged? Well, since this is a fraction, we just eliminated the fraction. Remember, you take whatever's on the bottom in a fraction, whatever's on the bottom, multiply both sides times that. All right, so this would cancel out over here because it's x minus 1 divided by x minus 1. So it leaves y minus 3 equals 2 times x minus 1, which is what the yellow equation is. It's the same one rearranged. Multiply by x minus 1. Okay, I can see that. So same equation of a line, just in a different form. So here's an equation for another line. Y minus 7 equals 1/2 x minus 5. What point do you know that this line passes through? Well, let's go back up here. We had a point that the line passed through. It passed through 1, 3. It also passed through x, y, but we don't know what the coordinates of that point is. But 1, 3, and when we moved it to our equation, it ended up y minus 3. 3 is the y of that coordinate point. X minus 1. 1 is the x of that point. So the point 1, 3 was right there. So using that same logic, it should go through. The x is right here. Don't forget, we switched, put the y on the left and the x on the right. The x should be 5 and the y would be 7. So that must pass through the point 5, 7. And what is the slope? Well, the slope here was 2. That ended up right in front of the parentheses in our equation. So the slope must be 1/2. Well, that's pretty nifty. Where's this equation been all our life, right? Yeah, now they were making us work a lot harder to get there. So let's see. Okay. Now let's write a general equation for any line. All right. So this line is specific right here. It has the point 5, 7 and this slope. So that is only describing one line. So let's look at any line. So we know the line passes through this point, hk. So that could be any point, right? H and k is variables. They could be any number. And we're going to say the slope is m. So write an equation that says the slope between those points. So we would say the point x minus h, much like we did up in our first equation up there. And, oh, wait, that's backwards. Give myself a star for doing that. Remember, the y's are on top. So it'll be y minus k. Rise over run. Y's are the rise, right? Y goes up and down on our graph. So that would be the rise. It has to rise up and down. So the y go on top. And the bottom would be the x minus h. And it would equal the slope of m. So the difference in the y's on top, y minus k, make sure it's a k, minus the x minus h. So let's look at this, same type of thing. Y minus k equals x minus h. How does that relate? It's the same thing that happened right here, right? Same equation. We just multiplied by the denominator times x minus h. I'll make that like an asterisk so it's not an x. Times x minus h. And then that'll take the x minus h and put it out there. So this right here is the point slope form of the equation of a line. Point slope. Why do we call that point slope? Because it gives us the point and the slope. This is called the point slope equation for a line. So let's use the point slope form now. So let's write an equation that describes each line. So we want the line that passes through the point -2, 8 and has a slope of 4/5. Give you a moment to think about that. If you have a piece of paper, have the notes, write that equation down. So we're going to use our generic form. Let me pull our generic form back here. Right there's the generic form. Y minus k equals m times x minus h. So using that in mind, I'll put that up here at the top of our page. All right, so y minus 8 equals, let's see, m, that would be slope, right? Even when we were doing y equals mx plus b, m was always a slope. So that hasn't changed. We're still using m in this equation here for slope. So the slope is 4/5. And then the x, that is a -2. So if we have x minus -2, we'd write that as x plus 2, right? Okay? See where we got that? Let's do another one. I'll leave the equation up there. All right, now the 0.07 with this slope. So y minus, what's the y? Y is always, it's an xy. Remember, it's always xy. Any point is always xy. So y minus 7 equals, slope is -7/3. And this is x minus 0. Now, if it makes you feel better, you can always put the -0 on there. But subtracting 0 does nothing for our equation, right? So x and x minus 0 is the exact same thing. So we don't have to put -0 on there. But you can. It's not wrong to do that. It's just this is simplified, and that really has some other stuff attached to it there. It would need to be simplified. But if it helps you remember how that relates, I don't mind you doing that. We're just learning this. Okay, so this one, again, we have the same situation. We got the 0, but this time it's the y. So this would be just y equals, or again, y minus 0 if you like, but there's really no need to do that. Slope of -1 parentheses. Again, the 1 is not really needed. Let me put it this way. It's just a negative out front, but the 1, when we multiply something by 1, it doesn't really have to be written, just a negative, x minus 1/2. All right, so y equals negative, parentheses, x minus 1/2, parentheses. How about the equation that describes this line? Well, there are many correct answers there. Because if we're using the point slope equation, we've got multiple points. We've got this one, this one, this one, this one. This one's not even marked, but that's a point. This one's not marked. That's a point. We have many points to choose from. We just need to use the correct slope because that's going to be the same. So rise over run. Pick any 2 points to figure the rise over run. So let's go. It rises 1 and it runs 2 to get to the next point. Now, if you skipped a point like you did up here with that point I drew in, it would go up 2 and over 4. And 2 over 4 simplifies to 1 over 2. That's the same thing. That's 1/2, right? 2 divided by 4 is the same as 1 divided by 2. So either way, our slope is going to be 1/2. So let's pick a point. Let's do this one right here. Let's make it interesting. Y minus, this is 2, equals 1/2 x minus 0. So just 1/2 x. We could choose a different point if we want to choose this one. This is the point 4, 4. So it'll be y minus 4 equals 1/2 parentheses x minus 4. Right, same way. Just there are 1, 2, 3, 4, 5, 6, 7 points on that graph that we could use. And so there's 7 correct answers. Again, love it when there's options that more than one way to get to the correct answer because there's more than one correct answer there. All right, using the structure of the equation, what point do you know the line, do you know each line passes through and what is the slope? Okay, so this time we're going to give you the equation and we've got to go the other way. So using what we know, back here, all right, back to this equation. Let me pull that down a little bit. All right, this is y minus k, x minus h, and we know it's the point HK, that is the point that it goes through. right? And the slope is, of course, m. So we have that information. The point, it'll go through the point x plus 4, x minus h. So h must be negative 4 because x minus negative 4 would be x plus 4. So there's the x. And y minus 5, it must go through that point with a slope equals the slope. 3/2, right? 3/2 equals the slope. How about this one? Y plus 2, so it must go to the point. Well, there's nothing after the x, so the x must be 0 and plus 2, so this must be a negative 2. So it must go through that point and have a slope equal to 5 because that's what's in front of the x, 5. Fabulous. This time we don't have anything with the y. So when we do our point, the y must have 0. X minus 5/8, so it must go to the point 5/8, 0. And the slope is negative 2 because we have that negative 2 out front. Okay, not so bad. I think we can handle that. Fabulous stuff. Let's move on and look at lesson 10. All right, lesson 10. Okay, you'll have problems from both lesson 9 and lesson 10. If you need to back up, review any of that, please feel free to do that. All right, lesson 9, lesson 10. Parallel lines. Let's talk about parallel lines. Draw any non-vertical line in the plane. Draw 2 possible translations of the line. Okay, non-vertical. So I'm going to make a point there, and I'm going to make, I'm using another pencil as my straight edge. Yeah, that wasn't real good. Make 2 points. And I'll just connect those 2 points. If my pencil stays here, I will connect those 2 points using my straight edge. All right, so going through those 2 points, there's line. Draw any non-vertical line. And 2 possible translations of that line. Okay, we know what translations are. That is not changing the size or shape. It's just moving the direction, right? So let's say it's going to translate down 2. So this point would move down 2, this point move down 2. All the points would move down 2. Every point on the line. So the new line would come right there. All right, there's one translation. And let's put one way at the top where it went up 4. Every point would go up 4. There are 2 possible translations of our original line right there. So find the slope of your original line and the slope of the images. Well, the one I drew is pretty simple. We can pick any 2 points, and it goes through points all along there. So our slope is up 1 over 1. Our slope is 1 over 1, which simplifies to just 1. 1 divided by 1 is 1. So that is the slope of the original line and the slope of the images. Let's look at this one. It goes up 1 over 1, up 1 over 1. Let's look at this up here. Up 1 over 1, up 1 over line. They're all the same slope, which would make sense because in a translation, all the points are moving the same direction in the same distance. So if all the points on this line move down 2, all the points, it would still have the same slope between those points. All the slopes move up 4. I mean, all the points moved up 4 still have the same slope between those lines. So with that in mind, let's move on to the next page. Here's what our next thing we're looking at. Okay, so Priya, we have Priya joining us again today. She wrote this proof. She says, all right, let's consider any 2 parallel lines. All right, we have this nice illustration to show us. Let's assume they're not horizontal lines, they're not vertical lines. So these are not, these are diagonal. Therefore, they must pass through the x-axis as well as the y-axis. That's true. So both of these lines at some point pass through this x-axis right here. And keep in mind that when that happens, it may be off of the graph when we see that. But in this case, it's on the graph. If we had steeper lines or something or more slanted down, it might not see where it does, but it would eventually. We know that because they go forever in every direction. So it will cross through both of them. So this forms two right triangles with a second congruent angle. So it's just saying this is a right triangle right here formed with the axis, right? So we can see that triangle. And we have this right triangle. And what she's saying is that this angle, let me see if I can put that in red. It's highlighted real lightly here. That one and this one, she said, are congruent angles. So two right triangles with a second congruent angle. We'll call that angle theta. The tangent of theta is equal for both triangles, so the lines have the same slope. She says the tangent of theta is equal for both triangles. Interesting. Let's see what we can figure out from her reasoning. How does she know the right triangles have a second congruent angle? Good point. She just said that these angles are congruent. How do we know that? How does she know that? Well, that goes back a ways in the year, but at some point in the year, if we put these this way, these are two parallel lines, right? Two parallel lines. I'm going to mark them as parallel. Those two lines are parallel to one another. And what we see is this line here is a transversal. Remember, two parallel lines cut by a transversal. It's a very steep transversal. Ours were usually a little more straight up and down or something, but this is still just a transversal cut between two parallel lines. So if those are two parallel lines and a transversal, that makes these two angles, what kind are they? You remember we had vertical angles, we had corresponding angles. These are both inside the parallel lines, and they're on opposite sides of the transversal. Alternate interior angles. Since those are alternate interior angles, those would be congruent. Alternate interior angles. Alternate interior angles. They are congruent. So that's how we know that. So it is a second angle that would be the same in those two triangles. And make sure you can see the two triangles we're talking about. We've got, this triangle here. That's one of the triangles. And then we have this larger triangle up here. All right, so we have those two triangles. So there's our two triangles. So show or explain what it means that the tangent of theta is equal for both triangles. Oh, I thought it would probably put us to do that. So what is the tangent? Remember tangent? We had SOHCAHTOA. Tangent was opposite over adjacent. So what she's saying, if we label these sides, let's call this triangle X, Y, and Z, and we'll call this one A, B, and C, just to give it some that we can talk about for the sides. So saying that the tangents are equal, that means the tangent, if you remember, is the opposite over the adjacent. That's not a good looking O at all. That's a better O. Okay, opposite over adjacent. The opposite for X, Y, and Z, if this is our angle that we're referring to, theta, let's go ahead and label it. So that's theta. This would be the same angle. The opposite would be the y, because it's on the other side of the triangle, y over x. So that's saying that y over x is equal to the other triangle. Here's theta. The opposite would be a. Adjacent would be b, equal to a over b. Now we know z and c are the hypotenuse, so those are not involved with tangent. So that's what it means by the tangent is equal for both triangles. So whatever the numbers are, if we had the distance of how long those lines were, x and y and a and b, we could set them up in this fraction, and it would be the same fraction. 3/4, 1/2, 5/7, whatever it is, they would be the same. So how does that prove that the parallel lines are equal to one another? How do we know they're parallel? The slopes of the parallel lines. How do we know the slopes are equal to one another? Well, if those are both equal to one another, then that proves that these are the same ratio. We know these have two angles that are similar in both of them. Those are similar triangles. So by having similar triangles, by having sides that are proportional to one another, all of this together big hints that tell us that since this angle and this angle is the same, these have to be the same angle. They would have to be parallel for many of those reasons. Similar triangles having, if these are proportional, then the other sides would have to be proportional as well. Because all of those ratios should set up to be the same, knowing what we know is true already. So there are many different ways we can look at that and see that Priya does know what she's talking about. Okay, prove your parallelogram. Now it gets a little tricky, right? Because now we're putting all of this together. We've got the equation of a line, and we want one that's parallel to this. Wild visitors from science department. Parallel to this, passing through this point. Well, this is our y equals mx plus b format, right? Y equals mx plus b. So we know the m is the slope. Now we have a point. So our equation, we should probably use the point slope. So y minus, what's our y? 1 equals slope 2 x minus a negative 4, right? Minus a negative 4, x minus negative 4. That would be the same as x plus 4. Now it's saying graph both lines described in the previous question. All right, let me pull up our graph here. Graphing software. Let me move myself out of the way a little bit. Okay, so we have y equals 2x plus 3. So there's the line 2x plus 3. Now a little bit in case we need to. There we go. And we'll add a second one, the one we just did, y minus 1 equals 2 times x plus 4. Oh, what happened to me? Oh, there it is. All right, x plus 4. All right, we have both of those graphed. So we can see right there our two lines. Well, let's go back and see what our problem says to do now. Draw a parallelogram using the two lines you graphed and negative 4, 1 as one of the vertices. Negative 4, 1. Okay, so let's go back and take a look at that then. Negative 4, 1 right there. It wants to do that as a vertices. So to make a parallelogram, I'm going to put a line there. There's at negative 4, 1. And did it tell us where to put the other one? It just said using that as one of the vertices. So we can choose where we want for the other one. So let's do right here at y equals 4. Let's make that easy on ourselves. Y equals 4. All right. So let's blow it up a little bit using there. Here is our parallelogram. It runs this green line to this red line to this purple line to this blue line. Fabulous. Okay, so let's go back and look to see what our problem said now. Prove that this is a parallelogram. Okay, so that leads us to what is required for a shape to be a parallelogram. We're going to need to prove that it has two. Why did I put it? We're going to need to prove that it has two sets of parallel sides, right? And that'll pretty much prove everything else, because for those sides to be parallel, the lengths that would have to be the same, or you won't have all of them parallel. So if we prove it has two sets of parallel sides, we can prove it is a parallelogram. All right, so let's go back and look at our shape. So to prove those are parallel, we need to prove those are the same slope, right? So if our blue line is the same slope as our red line, and the slope of the green and purple lines are the same. So let's start with the purple line. What is the slope of this line? All right, so it starts over here. We have 2 points, negative 2.5 and 4. And 0.5 and 4. 4 is the y, right? So the y, if we did the difference between those, 4 minus 4 Well, on top of our fraction, we're going to have a 0. So it really doesn't matter what's on the bottom of the fraction because 0 divided by anything is 0. So the slope of the purple line is 0. So what's the slope of the green line? The y is 1. The y here is also 1. Let me click on that one, got all those points. Since the y is 1 and the y is 1, again, you get a 0 on top of the fraction. We have two lines that both have a slope of 0. All right, so let's look at the red and blue line. What is the slope of those? So let's start with the blue one. It goes a rise of 1, 2, 3, and a run of 1.5. So 3 over 1.5, that would equal 2. 3 divided by 1.5. And what do we have in the red one? 1, 2, 3 divided by 1.5. 3 divided by 1.5 equals 2 once again. So looking back at what we had, the red and blue lines, red and blue, had a slope of 2. The green and purple in ours had a slope of 0. So we have two sets of parallel sides by proving they had the same slope. So if you're trying to graph, you can always go to desmos.com, desmos.com, and it has the graphing. You just click the button to start graphing. You can graph lines if you didn't remember that, and that will help you. There's also a link to a Desmos calculator. This is the graphing calculator. There's a scientific calculator that we posted on Google Classroom, and that's just for doing like tangent and cosine and 2 times 3 and those kind of things. This is the graphing calculator that I just clicked on the button that said start graphing. So let's see. Are you ready for more? Is that all a problem? Then we have the summary in the back. Okay, so are we ready for more? Let's look real quick at this. Prove algebraically that the translation xy to the rule plus p plus q takes the line y equals mx plus b to a line with the same slope. Proving that algebraically. Let's talk through it. I don't want to go through all the work. I know our video is getting a little lengthy already. What happens here? Whatever p is, let's say p is 2 and q is 5. Every point we would add 2 to all the x's and add 5 to all the y's. Well, what we saw with our graphing just a moment ago is if we just add to a line, let's delete these and just have this one right here. All right. If we take the same equation, first off, y minus 1 equals 2 times x plus 4. Okay, I've got the exact same line. If we just added 2 to the x, made it 6, and we added 5 to the y, so that become negative 1 become plus 4. It's the same line, right? Same slope. It's a line with the same slope. By the same token, if we take that one and we did a different transformation, p and q being different numbers, if we made it y minus 1 be y minus 3, how about that? We'll go that direction. And instead of plus 4, be 2. That makes p and q different numbers. Still, we have lines that have the exact same slope. So adding to the p and q, as long as we're adding the same amount to all the x's and y's, it's just going to move the line as a translation, which should have the same slope. So that's all of the lesson. If you want to review that, go ahead. If you want to do the notes, blanks, and see if you can do that, that's great. But you do have an assignment posted, so let me know if you have any problems. I'll be online between 10 and 11:30 in the morning where you can chat face-to-face. We'll have my camera on and all that good stuff. But let me know. And until then, we will see you.